Hello guys, here Mr. Yi with another question for the grade 12. This time we're going to be solving question 3 from the mid-year diagnostic exam done and developed by Professor Rodriguez. This is a 2023 June exam in actual fact. This is going to be the projectile motion for the grade 12. The question said a rocket is launched vertically outward. At a height of 4 kilometers above the Earth's surface, an empty fuel tank is released. At this moment, the velocity of the rocket is 250 meters per second upward. Ignore the air resistance on the tank. The motion of the tank is said to be in free fall and define the term free fall. Now, what is free fall? Free fall is a motion. It's a motion of an object during which the only force acting is the gravitational force. A very simple definition, guys, that for sure is going to be in the exam question related to projectile. Question 3.2, calculate the following, use only equation of motion. So we cannot use either energy or any other method, only equation of motion and the maximum height above the ground level that the tank will reach before falling back to the earth. So let's have a little analysis here on that situation there. Okay, we have a rocket that is moving upward, it's moving in that direction, all right? Now, at this specific height, we're going to say that this height here from the ground is 4 kilometers. And we are going to convert to meters, and it's going to be 4,000 meters. At that specific point from the ground, the rocket releases a tank and is going to continue moving upward. So at that specific point, the rocket releases the tank and continue moving upward. Now, important to know first, this rocket is not in free fall and is not a projectile, okay? So the rocket is not part of the question, but the tank, let's say this one here is the tank. Now, what does the tank do? Because of inertia, this tank is going to move first a little bit up before it's moving down all the way to the ground. So this is what is going to happen. It's going to move a little bit up. That happened because of inertia. You need to know that the initial velocity of the rocket is given to you and it was 250 meters per second. So that is also the initial velocity of this specific tank, 250 meters per second. I'm not going to write direction right now, this up, just in case, okay? So that is very important, and this question has to calculate the maximum height above the ground. So the maximum height above the ground, guys, is going to be the height from the ground, which is the 4 kilometers, this distance which is 4 kilometers or 4,000 meters, plus this distance that this rocket is going to move up, which we are going to call delta y. So the whole distance from ground to there is what is going to be the maximum height above the ground. So all we need to calculate is this delta y to know the maximum height. And there is when we go into this question 3.2.1. We're going to first write data real fast to see what we have, okay? So we have first of all that the initial velocity is going to be 250 meters per second. But before we carry on, we are going to select the direction. And remember, the direction is entirely up to you. I am going to write up is positive for the entire question probably, but you can't change, it's up to you. Okay, so if I said up is positive, then the initial velocity here is positive. Okay, what other data I know? I know when the object is at this specific point, which is the maximum height, the velocity is going to be equal to 0. So I'm going to write it here. The final velocity is equal to 0 meters per second. Guys, remember I'm working for this specific point from there to there. I'm working for this to calculate that delta y. So let's do here, this delta y is going to be the question mark right for now. We don't have the time, we also have the acceleration due to gravity, which is 9.8 meters per second squared, but because it is down and up is positive, the acceleration due to gravity is going to be negative okay? And that is all the data we have for here. So what formula can we use to help us calculate this one there? When you go to the formulas, which is here, this here is the formula that is going to help you according to what we have. These two are the same, all the formulas within the same row are the same. They're just using the different symbol. This one is for y, so in actual fact is this one that have the delta y. You have the final velocity, you have the initial velocity, you have the acceleration, and you have the displacement. All the other formulas will have time, which is not the case. We don't have time, and therefore it will be more difficult to calculate it. So final velocity square is equal to initial velocity square plus 2 times acceleration due to gravity multiplied by the displacement. We're looking for the displacement, so don't get lost in here. And when you substitute, you have that 0 square is equal to positive 250 square plus 2 times minus 9,8 multiplied by the displacement there. Okay, let's move all that. There we go. So now if we rearrange this one, we will have that is negative 62,500. This one is the 250 square is equal to negative 19,6 delta y, and when you rearrange this one, you get that delta y is equal to minus 62,500 divided by minus 19,6, and then we'll get that delta y is equal to 3,000, it's a positive 3,188,78 meters. This is the displacement. Now remember, this displacement is not the answer of the question. This displacement was this distance. They want the final answer they want is from the maximum, is from the ground. So all they want is the maximum height from the ground. That will be equal to the 4,000 distance that is from ground to release point plus the 3,188,78, and this maximum height, which is what they actually want, is going to be equal to 71,000 or 7,188,78 meters. This is the maximum height the object reached from the ground, and therefore that is the final answer of this specific question. It's a very good question to practice, guys, and Projectile, you done it quite long ago, so I hope you understand this question. Let's go to the next one. Calculate the time taken by the tank to reach the ground after it has been released. So now I want you to note something. If we go here to the picture again, all they want to know is how long this rocket started from this point to the ground. Okay, so if we do that, then the displacement is going to be in this direction. This is going to be the whole displacement for now this question, which is 4,000. Okay, that is the displacement for the new question, and they want to know how fast it's going from this point to the ground. It doesn't matter the path that ball took. Okay, so that is important. All right, so we are going to be solving this question in a new page. So this is question 3.2.2, and the data we have for this question is, first of all, we are going to select up as positive again. All right, we're going to keep doing up as positive, but you can change the direction, it's not a problem. So what do we have? We have that the initial velocity is equal to positive 250 meters per second. We have that the displacement, remember we said it's going to be from starting point to final, so it's negative 4,000 meters. We have the acceleration due to gravity, which is negative 9,8 meters per second square. We have that we are looking for the time, so it's part of the data, and that is all we have because it's from starting point to the ground. Okay, so saying this, if you go to the formulas, The best formula that can help us is this one here. Why? Because we have the initial velocity. We cannot use this one because we don't have the final velocity. Now, what people do is people start calculating time to go up, time to go down. I'm not going to do that. We here are going to use one formula to calculate the time, which is the displacement is equal to the initial velocity multiplied by the time plus the half multiplied by acceleration due to gravity multiplied by time squared. Now, I want you to note something. People get very confused about this one. I don't think it's a problem because lately we use calculators, so it's not a problem to do the calculation. The big amount of marks in this question is going to be in this part here. So regardless what calculation you do, and if you struggle, you'll get most of the mark in this part and only one for the final answer. So don't struggle looking for different formulas because you're going to lose marks, or you may lose marks. So if we go here and we substitute what we have, then it's going to be minus 4,000, that is the displacement there, equal to initial velocity, which is 250 delta t, plus half, 9,8 is negative, minus 9,8 multiplied by delta t squared. And I want you to know the following. This question is 4 marks. 1 for selecting the correct formula, which is that one. 1 for the substitution on the left hand side, which is the 4,000, and 1 for the whole substitution on the right side, which is the final mark. Guys, there is only 1 mark left, which is for the answer. I am not saying you mustn't get the mark. I'm saying you shouldn't struggle or worry about that one, okay? So this is most of the marks of the question. The rest is the calculation. So let's do the calculation real fast here, and let's do it very slow. We have 4,000 on this side, which is equal to 250 delta t minus, when you solve this part here, you'll get that is minus 4,9 delta t squared. We're going to rearrange this formula, and we are going to move this 4,000 to the other side. So we're going to go and move this 4,000 here to the right hand side, okay? So what we are going to have then here, minus 4,9 delta t squared plus 250 delta t. I have it exactly as it was before, it didn't change. The 4,000 is negative, is going to be now positive 4,000 equal to 0. And we have here a quadratic equation, which is what I told you. It's nothing to worry because all you have to do is to substitute in a calculator. However, for you to remember, this is going to be a quadratic equation of the form ax squared plus bx plus c equal to 0. And we are going to solve for x. If we're going to solve for x, x is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. So this is what we're going to use to calculate the time. And as I said, you punch everything in your calculator. So if we say that, we have that the minus 4,9, this one is a. We have that 250 is b. And we have that the positive 4,000 is c. Alright, so we are going to come and we say delta t is equal to minus b, which is minus 250, plus minus square root of b square is 250 square, this is a 50 there, minus 4, I'm going to open bracket, for a is minus 4,9, be careful with the signs, bracket again, and c is 4,000. If you make a mistake here, then the answers are going to be wrong. Divided by 2 multiplied by a, which is minus 4,9. And guys, you punch everything in the calculation. Now here you will have 2 answers. You will have one answer when you use the plus, and you will have an answer when you use the minus. So if plus and if minus. So if you use the plus, then the answer for the time will be equal to minus 12,79 seconds. And guys, the answer cannot be negative. time cannot be negative. So when you substitute the minus, you get that the time is going to be equal to 63,81 seconds. That is then the correct answer for this specific question. I hope you understand. It seems intimidating, but it's not really difficult, guys. Now, this one here is the final mark. This one will carry 1 mark. Now, the final question calculates the speed of the tank just before it reaches the ground. And for this one, we are going to use again the starting point and the final point. The starting from beginning here, so when the object was moving up, to the ground there. Once more, we're going to say up is positive, and then the data we have for this question is the initial velocity is positive 250 meters per second. The time we just calculated, the time that take to reach the ground, which is equal to 63,81 seconds. We have the final velocity, we are looking for it, and then we have acceleration due to gravity, which is minus 9.8 meters per second. It's quite simple, so now we can use the specific formula there. I'm not going to go to the formulas. I did show you how to do it, but the most suitable one for this one, according to the data we have, is the final velocity equal to initial velocity plus acceleration multiplied by the time, and the final velocity then is equal to 250 plus minus 9.8 multiplied by the time, which is 63.81. And when you calculate this one, you get that the final velocity is equal to, remember here is a minus 9.8, and you get that the answer is going to be a negative 375.34 meters per second. Now be careful here. The question said calculate the speed. So the speed doesn't have direction. The final answer will be that the final speed is equal to 375.34 meters per second. That is the final answer for this specific question. I hope that is clear. It's really not too bad, guys. So let's go to the final question here. And the final question is for a graph. They say sketch the velocity times graph for the complete motion of the tank. Now, what we're going to do, this is going to be a rough graph here on this side, and then we're going to complete. This is velocity and this is time, and what is going to be happening there. For the entire motion, we took up as positive as we are going to do that. The velocity of the object was somewhere positive because it was up positive. It's moved all the way to a maximum height where the velocity is 0, so it moved all the way to there. And then continue moving all the way, all this must be in straight line, all the way up until it reaches the ground. So that is the graph. That is the graph. We're going to do it on this side here. So here we are. Now, what is going to be the initial velocity of this specific tank? It was positive 250. Positive because I said up is positive. So that one is entirely up to you. The object moved all the way to a maximum height in which the velocity is going to be 0. So this graph is going to be in straight line all the way to the x-axis. Here at the x-axis, remember this means at maximum height, h maximum. That is why the velocity there is 0. Alright, now what happened there? It changed direction. So change direction, it means it's going to the negative side of the axis. Alright, the negative sides mean different direction. Okay, so let's write that little note there. As it moved to the negative side, it changed direction. Straight line still, because there is a straight line graph here. But now this object start moving from the maximum height all the way straight up until it reaches the ground eventually. So at the ground, remember velocity was higher than that one. So at the ground, and this is not accurate, we did calculate the velocity, and at the ground, which is going to be, let's say, here at the ground, the velocity of the speed of that object was 375,34, 375,34 if I'm not mistaken. Here we are. Yes, that is the value. So that one is negative because we set up is positive. Remember, the negative and the positive here have to do with what you select to be positive and negative. And how long it took for the entire motion, guys, we also calculate that one, and the time was equal to 63,81 seconds. And guys, this is the graph. So this is the end of the question. This one is question now 3.4. I hope you understand. It's a very good question to practice, and most now that this long ago that you did this question on this topic on projectile. I hope it helped. Thumb up if it did help. Subscribe for the channel. I'll come with another question next time. Will be momentum probably. I'll see you next time. Mr. G here.